Today our topic is valency. The valency of an element is determined by the number of electrons in its outermost shell. Valency is also an important concept in chemistry because it helps us understand how atoms join together and to form molecules. All atoms not stable with a single one. It always tries to react with another atoms and then it becomes more stable. Here we see the valencies for 1 to 10 elements. First, hydrogen. Hydrogen atomic number is 1. Its electron configuration is 1s1. Here, hydrogen having 1 electron in its outermost shell. That's why it is having 1 valency. Here, it means plus 1 means it gives it electrons to another atom. Then it becomes molecule. Here we see the hydrogen chloride. H plus 1 charge, chlorine minus 1 charge. It forms a molecule. Then it's more stable. Helium. Next, helium. Atomic number is 2 and its electron configuration is 1s2. It is a noble gas. It doesn't react with another atom because it is very stable. Next, third one is lithium. Lithium, its electron configuration is 1s2, 2s1. In its outermost shell, it's having 1 electron and here is 2 electrons. It's stable with helium. Then it's try to give it electron to another atom. That's why it's having plus 1 valency. For example, lithium chloride. Its formula is lithium LiCl. It's having plus 1 charge, here having minus 1. Then it's stable. Beryllium. Its atomic number is 4 and its electron configuration is 1s2, 2s2. Here stable with 1s2 helium. After it gives it electrons to another atom, then it becomes stable. That's why it's having plus 2 valency. For example is barium chloride BeCl2. Chlorine having minus 1 valency and beryllium having plus 2. That's why it's becomes stable. Next, boron. Boron atomic number is 5 and its electron configuration is 1s2, 2s2, 2p1. Here having 1s2. It represents helium. Then it's having in its outermost shell 2 plus 1, 3, total 3. Its valency is plus 3. For example is boron trifluoride. Boron trifluoride after carbon. Carbon 6. Atomic number is 6 and its electron configuration is 1s2, 2s2, 2p2. It represents helium. After in its outermost shell it's having 4 electrons. That's why it having 4 valency. Carbon is most important for organic chemistry. It plays main role in organic chemistry. That's why its valency is 4. Its formula is carbon tetrachloride. That's why it is the structure carbon tetrachloride. Next, nitrogen. Nitrogen atomic number is 7 and its electron configuration is 1s2, 2s2, 2p3. Here having it represents 2s2, 2p3. Here is helium represents. After in its outermost shell it's having 5. It is also having plus 5 valency and 2p3. It's a gain with here we see the noble gas neon 10. Its atomic number is 10. It gains 3 electrons. Then it's stable. That's why it is also having minus 3 valency. For example, we see the nitrogen, ammonia. Nitrogen is minus 3 and hydrogen is plus 1. Total its structure is ammonia. After oxygen, atomic number is 8 and its electron configuration is 1s2, 2s2, 2p4. It is also near with neon noble gas. it gains 2 electrons. Then it becomes stable. That's why it's having -2 valency. For example is water. Water structure is here. It is a water structure, and formula is H2O. Here oxygen having -2 and hydrogen is +1. Total it is stable with H2O. After fluorine atomic number is 9 and its electron configuration is 1s2, 2s2, 2p5. It's in its outermost shell. It's having only 1 electron. It gains 1 electron and then it becomes more stable. That's why it's having -1 valency. For example is carbon tetrafluoride and boron trifluoride. Structure is B and carbon tetrafluoride. Carbon valence is 4. That's why it's having structure. After neon, it is a noble gas and its electron configuration 1s2, 2s2, 2p6. It is more stable. It doesn't react with any atoms. These are the examples. Okay.